Welcome back to the channel. In today's video, we're diving into one of Python's most powerful features, decorators. Decorators are commonly asked about in technical interviews because they allow you to add functionality to existing functions or methods in a clean and reusable way. Whether you're familiar with decorators or just getting started, today's practical examples will help you understand how they work and how to tackle common decorator interview questions. Let's get started. Definition: decorators in Python are a really powerful and flexible feature that lets you modify or extend the behavior of a function without changing its actual code. Think of a decorator as a function that wraps another function, adding something extra to it like logging or timing, while still keeping the original function intact. It's like enhancing the function's behavior without rewriting it. You simply apply a decorator using the decorator underscore name syntax right above your function definition. This makes your code cleaner, more reusable, and easier to maintain. Whether you're adding authentication, tracking execution time, or any other functionality, decorators make the process simple and efficient. Now that we've covered the basics of what decorators are, let's dive into some practical examples. We'll see exactly how they work step by step. These examples will show you how to apply decorators in real-world scenarios, like adding extra functionality to a function without modifying its core logic. This is where things really start to get interesting. So let's take a look at how to use decorators in action. 1. Basic decorator. Question: write a decorator that prints executing function before calling the original function and prints function executed after the function call. This code illustrates how a Python decorator works by enhancing a simple function's behavior. A decorator in Python is essentially a function that wraps another function to modify or extend its behavior without entering the original function's code. In this case, the decorator is called by underscore decorator. It takes a function func as its argument and defines an inner function wrapper which adds some additional logic. The wrapper function prints executing function before calling the original then function using func and then prints function executed after the original function has run. It also captures and returns the result of the original function, preserving its return value if needed. The decorator is then applied to the say underscore hello function using the my underscore decorator syntax. This syntax is shorthand for wrapping the say underscore hello function with my underscore decorator. When say underscore hello is called, it doesn't just execute the original say underscore hello logic of printing hello. It first runs the additional code inside wrapper which adds print statements before and after calling the original function. As a result, the output includes the messages executing function hello from the original function and function executed from the decorator. This example shows how decorators provide a clean and reusable way to extend or modify functions, making them a powerful tool for tasks like logging, authentication, or timing without modifying the core functionality of the functions themselves. 2. Decorator with arguments. Question: write a decorator that accepts a function and its arguments and prints both the arguments and the result of function. This code demonstrates how to use a Python decorator to print the arguments passed to a function and the result of the function after it executes. The decorator named print underscore arguments is defined as a function that takes another function funcs as its argument. Inside print underscore arguments, a nested function called wrapper is defined. The wrapper function is responsible for modifying the behavior of the original function by printing the arguments and the result, while still calling the original function with the provided arguments. The wrapper function takes args and quads to capture any positional and keyword arguments passed to the original function. The first thing it does is print the arguments by formatting them into a string with the message arguments args quarks. After printing the arguments, the wrapper calls the original function using func args quarks and stores the result. Once the result is obtained, it prints the result using printf result. Finally, the wrapper returns the result of the original function to maintain the same functionality as the original. Next, the decorator at print underscore arguments is applied to the add function, which takes two arguments a and b and returns their sum. The decorator enhances add by printing the arguments passed to it and the result of the addition. When the decorated function add3 5 is called, the decorator's wrapper function is invoked, so it prints the arguments 3. 5 and then computes and prints the result 8. This code showcases how decorators can be used to add extra functionality to functions without altering their core logic, making it useful for tasks such as logging or debugging. 3. Chaining multiple decorators. Question write two decorators, one that prints starting before function execution and another that prints ending after function execution. Apply both decorators to a function. This code demonstrates how multiple decorators can be applied to a single function in Python. In this example, two decorators start underscore decorator and end underscore decorator are defined to modify the behavior of the greet function by adding behavior at the beginning and end of its execution. First decorator start underscore decorator. This decorator adds a message at the start of the function's execution. The wrapper function inside start underscore decorator first prints starting and then calls the original function funcArts quarts with the provided arguments. This decorator doesn't alter the function's return value but simply prints the starting message before executing the original function. Second decorator end underscore decorator. The second decorator end underscore decorator modifies the behavior after the function is executed. The wrapper function in this decorator first calls the original function funcArts, quarts and stores its result. After the function has completed, it prints ending and then returns the result of the original function. This ensures that the ending message is printed after the function has been executed. The two decorators are applied to the greet function, which takes a name as an argument and prints a personalized greeting, e.g., "Hello, Alice." The decorators are applied using the at syntax with a start underscore decorator placed on top of at end underscore decorator. This means the start underscore decorator will be applied first, followed by the end underscore decorator. When the greetAlice function is called, the start underscore decorator is executed first, printing starting. Then control is passed to the end underscore decorator, which calls the original greet function, printing hello Alice. After greet finishes executing, the end underscore decorator prints ending. The output is a sequence of messages that indicate the start of the function, the greeting, and the end of the function. By layering multiple decorators, this example shows how you can modify or enhance a function's behavior in a modular way, controlling different stages of its execution before and after without altering the function's core logic. 4. Class-based decorators. Question write a class-based decorator that tracks how many times a function has been called. This code provides an example of a class-based decorator that counts how many times a function has been called. The class call count serves as the decorator and it tracks the number of calls made to the decorated function using its underscore underscore call underscore underscore method. When the class is initialized through its underscore underscore init underscore underscore method, it receives the function to be decorated func and stores it in the self.func attribute. It also initializes a self.count variable which is set to 0 initially. This variable is used to count how many times the function has been executed. The core functionality happens in the underscore underscore call underscore underscore method, which is invoked every time the decorated function is called. Inside this method, the count is incremented by 1 each time the function is executed, and a message is printed to show how many times the function has been called so far. After updating the count and printing the message, the original function self.func is called with any arguments, args, and quarts that were passed in. The result of the original function is returned as expected, ensuring that the decorator adds functionality without altering the original behavior of the function. The decorator is applied to the say underscore hello function using the at call count syntax. When say underscore hello is called multiple times, the decorator tracks and prints the number of times it has been invoked while still executing its original task of printing hello to the console. For each call, the count is incremented and the message function has been called x times is displayed before the original output of the function. This example illustrates how class-based decorators in Python can maintain state, such as keeping track of how often a function is called, which is particularly useful in cases where more advanced functionality is required beyond what a function-based decorator might offer. 5. Passing arguments to a decorator. Question write a decorator that accepts an argument as string and prints it before executing the function. This code demonstrates how to define a decorator that accepts an argument, adding flexibility to the decorator's behavior. In this case, the decorator takes a message as an argument and prints it before executing the decorated function. The decorator underscore with underscore arg is a higher order function that takes a message as its argument. This allows the decorator to receive and use this message when modifying the behavior of the decorated function. Inside decorator underscore with underscore arg, A new function decorator is defined, which serves as the actual decorator. The decorator function takes a function func as an argument and it defines the wrapper function inside it. The wrapper function wraps around the original function, adding additional behavior before calling the original function with its arguments args and quarks. When the wrapper is executed, the message passed to decorator underscore with underscore arg is printed using print message. After printing the message, the original function is invoked using func args, quarks, and its result is returned. The key idea here is that the message is passed when the decorator is applied, giving it dynamic behavior depending on the argument provided. To demonstrate this functionality, the add decorator underscore with underscore art, this is the decorator message decorator, is applied to say underscore hello function. This means that the say underscore hello function is wrapped by the decorator underscore with underscore art with the provided message. So every time say underscore hello is called, it first prints the message, this is the decorator message, and then proceeds to print hello as part of the original function's behavior. This example shows how decorators can become more flexible and customizable by accepting arguments, allowing them to alter their behavior based on the input provided when the decorator is applied. This pattern is useful for adding additional functionality like logging, authentication, or debugging, where different parameters might be required in different cases. 6. Logging decorator. Question: write a decorator that logs the name of the function being called before executing the function. This code demonstrates a simple logging decorator in Python designed to log the name of a function each time it is called. The decorator log underscore function underscore name wraps around a function and prints its name before allowing the function to execute. This is a common use case for decorators providing useful logging information without altering the original function's logic. The decorator itself is a function that takes another function func as an argument. Inside the decorator, a nested function wrapper is defined. This wrapper function is responsible for modifying the behavior of the original function by adding a logging step before the function is executed. Specifically, it prints the message calling function func.__name__, where func.__name underscore retrieves the name of the original function being decorated. After logging the function's name, the wrapper calls the original function using funcargs. Quarks to ensure that the function's behavior remains unchanged and its arguments are passed correctly. The result of the original function is returned by the wrapper to maintain the function's return value. The decorator is applied to the say underscore hello function using the at log underscore function underscore name syntax. This means that every time say underscore hello is called, it is first processed by the decorator. When say underscore hello is executed, the decorator prints the message calling function say underscore hello before running the original say underscore hello function, which simply prints hello. This example shows how decorators can be used to inject extra functionality such as logging without changing the core logic of function. This approach is particularly useful for tasks like monitoring, debugging, or auditing function calls in a larger codebase. 7. Execution time decorator. Question: write a decorator that measures and prints the time it takes for a function to execute. This code demonstrates a Python decorator that measures the execution time of a function, providing valuable insight into the performance of the decorated function. The decorator execution underscore time wraps around the target function and records timestamps both before and after the function is executed. When the slow underscore function is called, the decorator touches the time at the beginning, allowing the function to execute as normal, in this case simulating a delay using time.sleep1. Once the function completes, the decorator captures the end time and calculates the difference, which represents the total execution time of the function. The decorator then prints the result formatted to 4 decimal places, showing how long the function took to execute. The output includes two parts. First, the message function finish is printed, which comes from the original function, and then the execution time is printed, displaying approximately 1 second. This example illustrates how decorators can be used to enhance functions with additional behavior, shown as the tracking performance metrics, without modifying the original function logic. 8. Checking user authentication. Question: write a decorator that checks if the user is authenticated before executing the function. This code illustrates how a Python decorator can be used to check if a user is authenticated before allowing access to a specific function. The decorator requires underscore authentication is designed to ensure that the decorated function only executes if the user is authenticated. The decorator accepts a function as its argument and defines an inner wrapper function that takes user underscore authenticated as a parameter along with any other arguments. Inside the wrapper function, the user's authentication status is checked. If the user is not authenticated, user underscore authenticated is false. The decorator prints user not authenticated, access denied, and exits without calling the original function. If the user is authenticated, user underscore authenticate is true. The decorator allows the function to run by calling the original function with the provided arguments. The decorator is applied to the access underscore dashboard function using the requires underscore authentication syntax. This means that every time access underscore dashboard is called, the decorator first checks the user's authentication status before proceeding. The access underscore dashboard function simulates accessing a restricted area by printing accessing dashboard if the user is authenticated. If the user is not authenticated, the function is not executed, access is denied. When the decorated function is called with access underscore dashboard true, the user is authenticated and the output is accessing dashboard. However, when access underscore dashboard false is called, the decorator detects that the user is not authenticated and instead prints user not authenticated. Access denied without running the original function. This example showcases how decorators can be effectively used to add access control logic, ensuring only authorized users can execute certain functions without altering the function's core logic. That wraps up our deep dive into Python decorators and the practical interview questions you might face. Understanding decorators will not only help you in interviews but also improve your ability to write clean, maintainable code. If you found this video helpful, don't forget to give it a thumbs up and subscribe for more Python interview prep and coding tips. Drop your questions in the comments below and I'll see you in the next video.